I had some interesting tech that I saw at CES. In addition to all the stuff I've already discussed on the show last week, I spent some time with our sponsor, Infineon, discussing some of their technology with some interviews. So I'm going to roll this now, and then Christian and I will be back. We're here at CES 2026 at the Infineon suite with Chevron talking about Wi-Fi 7, specifically the Wi-Fi Alliance just made an announcement that they were allowing 20 megahertz support for Wi-Fi 7 devices. So you have a solution for that. And I want you to tell us what that brings to the table for the products that my audience is going to be using in the future.
Yeah. So it's actually super cool that the Wi-Fi Alliance did this. Just for some context, people have heard of Wi-Fi 7 for about 2 years now. But devices that require a lot of data rate, like things like laptops and smartphones and so on, they could be certified as Wi-Fi 7 devices.
That's a done deal.
That's a done deal.
We're all there.
So until this announcement from Wi-Fi Alliance happened, the benefits of Wi-Fi 7 could not be brought to IoT devices.
So you're talking doorbells, smart
door
vacuums,
locks, smart cameras,
earbuds that have Wi-Fi or whatever.
Sure, garage door openers, your robotic vacuum cleaners, appliances in a house, smoke detectors, all these types of devices that we commonly use on a day-to-day basis.
Right.
The benefits of Wi-Fi 7 couldn't be brought to those until this announcement from the Wi-Fi Alliance that you were referencing earlier.
Absolutely.
And we now have a product. We are super excited to be bringing out this product, which we call the ACW741X. That does exactly that. It brings the benefits of Wi-Fi 7 to the world of IoT.
So in a kind of a higher perspective view, what are those benefits? And then let's dig into some tech and show us practically here with the setup what the benefits are.
So before we talk about the benefits, let's talk about the problem, right?
Yeah,
what is it solving? Now, if you look at the number of devices in a home, like pre-pandemic, you used to have 10 or 15 Wi-Fi connected devices in a home. That number has been growing a lot since the pandemic. Yes, I have about 48 in my house, and I'm probably one of the lead adopters. But most American homes today have about 30 to 35 devices. And that number is growing. And we project that by end of the decade, there'll be over 50 connected devices in an average home. And the problem is not just that you have 50 devices. Your neighbor on the one side has got 50 devices. The neighbor on the other side has got 50 devices too.
And now I live in a high-rise in Vancouver, Canada. So that means that I have all my neighbors as interference, and they might not have Wi-Fi 7. So, it's a mess. Right?
Exactly.
And you got 2.4, you got 5, you got 6 as well. If they have 6E in their homes and neighbors, right, they don't have 7. But I have 7. So what's the benefit for me now?
So when you have a device that's, if it's, let's say, dual band capable, if you operate in 2.5 and 5 gigahertz, with Wi-Fi 6, while you can use both bands, you can use only one at a time. So when you make a connection, you have to pick which band you want to connect.
And you have to reconnect if there's interference or something.
Exactly. If you don't like that band, you have to disconnect, you have to reconnect.
Whole handshake and all the time it takes to do that.
It takes anywhere from 5 to 10 seconds, sometimes even more than that. Now, that's the problem that Wi-Fi 7 for IoT solves. So what you can do with this is you can make multiple connections at the same time. So you can connect in 2.4 and 5 gigahertz while you make the connection, and dynamically switch whichever band you like.
Cool. So you have a demo for us that actually shows that.
Yes,
and shows the improvements in latency around that.
Right. So let me set this up for you. I've got 3 devices here. There's a Wi-Fi 6 device. It's a Wi-Fi 7 device, which is built with the chip we just announced, ACW741X. And we have a device here which emulates interference. The 50 devices, the 100 devices we talked about, this kind of creates traffic to emulate that interference.
This is FCC's worst friend right now.
Exactly, yeah. So these 2 devices are now connected to a Wi-Fi 7 access point. And what you're seeing here on the chart here is a latency of a packet that's going on the network. So the y-axis is the latency. X-axis is the passage of time. Now, both these devices, as you can see, are connected in 2.4 gigahertz now. Everything's looking good so far. There's some latency spikes. That's because there are other Wi-Fi devices in the vicinity here, and therefore you're seeing these little spikes here. But now let's create some interference in this band. So let's start with 2.4 gigahertz, and we create some interference. So this device will produce a lot of data. Now, when that happens, notice what happened to the Wi-Fi 6 device, right?
Yeah.
It lost connection.
It's trying to reconnect,
and so on. Whereas you look at the Wi-Fi 7 device, super cool. It noticed that
it switched.
The spike here, it noticed that there's a lot of latency. It jumped onto 5 gigahertz spectrum. Latency is still pretty low.
Fantastic.
And that's the switching time. And And look at that. It could switch in like under roughly half a millisecond. So imperceptible to the,
Yeah, I mean,
to
if
the
you're
user.
streaming from
really.
your doorbell right now, you won't even see a glitch.
You won't even see it.
And
right?
that's kind of
Whereas the
the
Wi-Fi
thing, right?
6 device, finally, after, I don't know, maybe 5 or 10 seconds there, reconnected, and it's still struggling because there's still a lot of
quite a bit of time.
interference and the latency is going up and down, whereas the Wi-Fi 7 device,
Wow.
smooth, right? Now,
Very nice.
now let's flip this around and try if it works the other way, right? So let's now inject some interference in the
5
gigahertz band. Okay, let's see what
Oh,
that
so
does
there's
here.
one-
Okay, here's a little spike. So the Wi-Fi 7 device detected that these two spikes here. It detected that the spectrum is crowded, and it switched over to 2.4. And once again, the switching time half a millisecond.
Right.
So there's still a little traffic here. You can see little spikes because of that. But look at the Wi-Fi 6 device.
Wow.
Still struggling. Wildly
It took a
fluctuating.
while, and it's starting to level out. but
Yeah, it's starting to
taken,
level out, but it took a while for
like
it to get there. Whereas
5
the Wi-Fi
seconds or
7
something.
was very
Yeah.
quick and easy. So that's the benefit
That's
of
great.
bringing Wi-Fi 7 to the
So
Wi-Fi.
now, obviously, I see the benefits. Like, with IoT devices, like the kind of the home device that we're talking about, the price is really critical, right? So obviously, Infineon is a solution provider for OEMs to make great products. Price is pretty critical. So I presume that this solution is available at a pretty reasonable price point, correct?
Yeah, I'm glad you brought that up because it's because Wi-Fi 7, the perception about Wi-Fi 7 is it's
a luxury
it's
thing.
expensive,
Right,
it's a
exactly.
luxury thing, and that was true because there are ways in which you implement Wi-Fi 7 which are more for the high performance devices, where the chips become much more complex because they're operating in two bands concurrently
Right.
at the same time.
Yeah.
So that is like using link 1 and link 2 at the same time.
And we're not doing that here. We're
We're not doing that here. We have the capability of operating in either link, and we just switch between the two links.
Right.
So this is a way of implementing Wi-Fi 7 without adding cost to the end system, so that IoT devices can afford
essentially the
it.
same cost as a Wi-Fi 6 device, right?
Practically. At the system level, it's practically the same cost because it's got the same dual band antenna, the same
Right.
BOM, and so on and so forth.
Fantastic. Well, listen, that was fantastic. Appreciate you sharing that info with us.
Thank you
I
very
think it's
much.
going to make everybody's vacuum robots better, which we all want. We want the robots to be happy, right?
Exactly.
So there you go. And now I'm here with Gary at the Infineon suite, and we're going to talk about some new tech. It involves coffee makers.
Yeah.
I'm a big coffee fan, so this is exciting.
I'm a big coffee fan as well.
All right, so Gary, tell us what you're
Let's
showing
take a look.
here.
So this is a coffee machine that's demonstrating one of our MCUs, which is our PSOC 4000T, which has multi-sense capability. It can also, not only can it do capacitive sensing, but
Yeah.
it can also do inductive sensing.
Fantastic.
And so the inductive sensing is used for like the metallic buttons here. So being able to sense the metallic deflection,
Yeah.
to be able to recognize button pushes. And that's for like very sleek, waterproof type designs where you can seal it all off. Okay.
So did you adapt a commercial product to
Yeah,
this? Okay.
we adapted a commercial product to
Because I'm
demonstrate this
quite familiar with
capability.
PSOC. So I also see you have some sort of capacitive strip device.
Yeah, so
here.
inside in here as well is this capacitive strip that we have for liquid level sensing.
Okay.
And so you can see it's showing the liquid level here on the screen
display.
here. And so because you can't really see inside the machine, we have this demonstrator here to show this. So this strip is inside the machine, and you can see over here there's a sensor showing the level of the liquid, and as I raise the level of the liquid up, you can see it goes up over there on the screen.
Yeah.
Right?
That's
And back down.
wow. Let me do it.
Yeah,
Real quick. I want to
please.
try this. You ready? Ooh, look at that. All the way.
And so it's air gapped as well, so it never has to touch the water.
That's really cool.
But it's able to actually use it. Yeah.
I like that you have it air gapped because that way there's no maintenance, right?
Correct. That's right. You don't have to deal with like a floating bob or anything like that
So-
that has mechanical issues.
This isn't really new, right? What's new here specifically for CES?
So for CES, we've actually this 4000T device actually is one of our first devices that combine both of these technologies together.
Okay. So I
So
see.
we've always had CapSense. We've had that for a long
I
time.
know, because I remember seeing that like through the wood as well. Like you
Yeah.
guys did the demos, I think 2 years
Correct.
ago. Or
We've
last
we've
year.
had we've been a leader in capacitive touch technology for over 20 years. Okay, so and so we've combined those two capabilities into one single device with the PSOC 4000T.
Okay, and then obviously my audience is very consumer focused, so coffee makers pretty good example.
Yeah, that's a
of how
good
you use
example
that.
of a
But can you think of other, like we've seen some smart water bottles that
Yeah.
measure how much you drink. Do you think this is an application?
Absolutely.
for that?
We've actually done that before. We've actually been in some smart water bottles that measure how much
Right
liquid
on.
you're consuming. Yeah.
And then what other applications do you think would be helpful? Like I suppose that in more industrial applications, being able to measure another liquid through a surface would also apply.
Yeah,
right? Is it just water or does
No,
it?
it can be done with other fluids as well,
Okay.
so like oil or other things as well.
Okay.
We also have the ability to measure foam in addition to the
Foam.
liquid. Yeah, so if
Wow.
it's a foamy or soapy liquid, we can measure the foam
that's
level as
really
well as the
interesting.
actual liquid level.
So can it kind of distinguish like the meniscus between like the how the foam kind of has like
Yeah.
the liquid, then there's just a little bit of a gooey meniscus
That's
thing, and then the
correct.
foam on top.
That's
Can
right.
it distinguish those three levels?
That's correct.
Wow. Okay, so that's really cool, right? And then of course all the capacitive, touch sensitive button stuff.
And again, this
that
device can
have.
support all the capacitive touch as well.
Oh, okay, it does that
And
too.
so, whether it's like maybe smart glasses where you're controlling it with capacitive touch, that's another example of where our devices are used today.
Now, another thing that's critical for consumer applications is price point, right? So PSOC is a pretty attainable kind of product, right? For
Yeah, it's very affordable. That's how we can do multiple, in high volume. Like, as I mentioned, smart glasses is an application.
Oh, okay.
So we can do,
Are you thinking like the temple control?
the temple control where you can slide to control like volume or different features.
Okay.
We that's one of our top applications that we service
Fantastic.
today as well.
Well, listen, Gary, thanks so much for the demo.
Yeah,
Appreciate it.
appreciate
From
it.
one coffee lover to another.
Right.
Expect your coffee maker to improve drastically soon with this technology. And I'm back here at the Infineon suite with Harry. Nice to meet you, Harry.
Nice to meet you.
You have a demo for us using a robot head. But there's something special about this robot head, right? You've got 60 gigahertz radar
Yes.
that you're helping, one of Infineon's latest sensors.
Yes.
Tell us about what you're doing here and what some of the applications would be in a kind of home environment or, consumer setting.
Definitely. So the radar sensor, it has on-chip detection built in. So
Yeah.
you're able to get presence information and motion detection by default from the sensor without the use of external computation. So you get like presence or absence information at a very low power basis. This is extremely useful for situations like security cameras, thermostats, even like robotic vacuums, anything
robot
where
vacuums, of course.
anything where you want to map the surroundings, understand if there is presence of people there, if somebody is entering or leaving the room, or even identify which area of the room there is occupancy, so that you can sort of take the next action based on it.
Right.
So it serves as like the information point of gathering environmental data.
So the big revolution of 60 gigahertz radar lately
Yeah.
has been it's come down in price and complexity significantly. Infineon's been a big contributor to that.
Yeah.
So do you think this particular sensor in this particular is something we could see today in some consumer products or very soon?
Yeah, definitely. 60 gigahertz radar has come a long way, and even the latest generation of Infineon's 60 gigahertz radar, like I said, it has a technological advantage as well, where we've moved on completely to CMOS. So this brings in like a good trade-off between performance, cost, and also the ability to do on-chip detection.
Yeah.
So this makes it very compelling to replace existing solutions and make it really low power and effective in terms of what you want to get out of it.
Great. So in this particular demo, you're going to show us a little bit. There is, the robot, because of its three sensors, I believe, is aware of the two of us being here.
Yeah.
And it can now use a time of flight sensor, to kind of rotate towards me. But it's if I'm closer, it's going to track me, and if you're closer, I'm going to move away right now.
Yeah.
And see if it actually tracks you.
Yeah.
There we are.
So basically
awesome.
the tracking is enabled by like the radar that is on the top, and obviously the time of flight gives you like the depth information and also the black and white
so
amplitude.
let's swap sides now.
Yeah,
You're going to
sure.
walk away a little bit, and I'm going to walk this way. And it's tracking me now. Yeah, okay. And if I move, it's going to track me, hopefully. Say hello, 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 hello. And now if you go over there, it should track you.
Yeah.
Yep. We're swapped sides. Okay, so it's working as advertised. But I think the thing that's really interesting to me on the map here is this, like it really knows everything that's around it at any time.
Yeah.
And, it's kind of cool to see the regular camera and then the infrared and the
Time
depth
of flight,
projector
yeah.
doing
Yeah.
this job here. So like if I get really close, you should be able to see my hand right there.
Exactly.
Yep. And then if I get further away, I get redder and redder, and you're closer to your green. Yeah, it's very cool. So, I thought you gave us a good example with doorbells, because you don't want the doorbell to be always on, right? Like video is kind of time. So, from a power consumption perspective, is 60 gigahertz radar less expensive than a regular camera that you'd find on the doorbell?
Yeah, definitely. If you're operating the camera all the time, it drains the battery quite a bit. Whereas if you have like very simple sensors like the PIR sensors, it turns on very frequently, so you get a lot of false positives. So this ultra low power mode of radar gives you like the perfect balance between the two. You have a reliable solution, but it's also lower power in the long term.
And then I guess another application is in cars too, right? Like, I mean, I know it's used for passenger detection and backseat and for airbag detection now, to decide how big the person is and stuff. But do you see a future? A lot of cars now have 360 recording for security, right? Kind of like. So, do you think that also something can run all the time? Because you're like 6 or 8 cameras are running all the time. You're draining the EV's battery while it's parked. Do you see an application for that as well?
Definitely. Automotive radar is a completely different market. There's a lot of other solutions available for automotive radar as well. But I would say that not only within the cabin, but also exterior, like you mentioned.
That's kind of what I'm thinking. Like to augment the radars for ADAS is one thing. But I'm thinking if it gets cheap enough, you could just add those just for surveillance purposes, right?
Definitely, yeah.
Okay, cool. That's another possibility. Anything else you can think of that might be applicable?
Yeah, no, I think we covered most of the key applications, but I think within the consumer realm, I would say that 60 gigahertz radar is becoming more and more compelling because of these reasons. Yeah.
Fantastic. Thanks so much, Harry.
Yeah, nice talking to you. Sure.
Folks, we have seen a bunch of really cool stuff today at Infineon, and I think CES 2026 has been all about robots and physical AI, as you know, but I think it's becoming real. I think that a lot of the technology we saw here are going to make it much more viable for your products, your tech in your home to actually work properly and not annoy you as much as it might do right now by running out of battery or not connecting to Wi-Fi properly. Because we all know that. You talk to your smart speaker and suddenly it's not connected. And you're like, I need a timer. I need it now. So, I think this is what Infineon helps with. And I'm always excited to see the kind of stuff that they're working on that's going to end up in products we see here at CES this year and next.